Hey everyone, welcome to the latest MassTransit bus stop. I got Drew Sellers with me today.
Hey Chris, how's it going?
Good, good. Is it hot in Texas? Is that a question?
Oh man, I think we're gonna break 40 Celsius.
I don't even know what that is, but I know it's at least 105.
It's hot.
So today we're going to talk a little bit about the database transport. I know we had a bus stop before where it was like, is a database transport a thing? Well, it actually is a thing now, and I did a video about that, maybe a few weeks ago.
But
Um,
it's time for an update, Chris. Like you can't be giving us these details and not, be feeding the fire of what this thing is. So I got a whole raft of questions we're about to plow through as someone that's not actually writing the code. This is what the people want to know. And the first thing is, does it work on Microsoft SQL Server?
it does. It was fun to port it over. In fact, it's amazing how you can go to something and say, hey, convert this function from Postgres to SQL Server. And it says, okay, is this close enough? And you say, that's close enough. I can take it from there. Some of the tools that are out lately are just really cool. But yeah, I did have to go deep into the documentation of SQL Server to understand the way common table expressions and some of the stuff works in SQL because Postgres has a lot of really cool fast features.
Hmm.
So it was a challenge. I had to relearn some SQL Server idiosyncrasies that just haven't really been an issue when you're at the entity framework level. But yeah, it's all native SQL. I even so with Postgres, I don't know if a lot of people know this, but Postgres loves lower snake case. Everything lower snake case, everything happy. Everything can be any case, but as soon as you uppercase something in Postgres, you got to put it in quotes, which is annoying as heck. So SQL Server, everybody loves Pascal case, or at least the people that I work with. So the mental translation of writing it so that it feels comfortable for people using SQL Server in the Pascal case table names and very much the way that any framework does it on SQL Server versus doing lowercase snake on Postgres. It's a little bit of a mental map, but I felt like it was worth it because I don't want people going into it and saying, "Oh, what are all these weird Postgres table names doing in my SQL Server database?" So,
Yeah, like just being aware of how the like that culture, what are their idioms, and trying to play nicely with them is just going to make it seem that less alien when they install it.
yeah, for sure. Especially since, I mean, we're talking about a SQL database here, which it uses SQL tooling. So being
Hmm.
able to go out and query the tables and say, oh, what are my queues, things like that. That's something people are going to do.
So riddle me this: we shouldn't use databases as a queue. That's a really common phrase when you start to get into these messaging driven communities where they're like, the database is not a queue. And then I think you hear, especially from the more pragmatic people, that your database is quite a bit faster than you think it is, right? Now, as you're starting to build out the database transport, yeah, and I know from our conversations that you're looking at like deep best practices in how to do what could be a high volume table. What level of throughput are you expecting to achieve with the database transport? Like, what's the optimal? If you're over this, like, don't even be looking at it. Like, the sweet spots here.
That's a good question. So I've and again, my testing is just locally with both SQL, Azure SQL Edge, and Postgres 14.7 running in Docker containers. I'm building a test suite to run this against RDS in Amazon,
Mhm.
which runs 14.7, I think. And I think Azure runs the same version. But locally in testing, if you're in the I need you know 3, 4, 5,000 messages a second realm, this is not for you. I mean, this
Mhm.
is definitely in the 1,000 messages a second or less area,
Mhm.
especially for Postgres. Now, Postgres has a lot of cool features like notification channels where we can do really quick reads. And the numbers I'm seeing with Postgres on a MacBook Pro M1 um, are over 1,000 messages a second, and that's just brute force pumping as many as I can into it and pulling as many as I can out. It does have the database transport does use prefetch, so if there's 100 messages in the queue and you have a prefetch at 10, it pulls 10 at a time. So the queries do scale; it's not doing one message at a time.
Mhm.
And the slowdown with SQL Server seems to really just be the polling interval. I mean, because of the fact that we don't have that notification channel out of SQL Server, all you have is the polling interval, and nobody wants to make 100 calls to SQL Server per second to see if
Hmm.
messages are ready. I just don't think you need that kind of latency.
Hmm.
So, for SQL Server, I definitely don't think you want, I mean, maybe you do. I don't know. If you own the database and you're paying a flat fee, query it all you want. I mean, it's in its own schema. It's in its own, you can put it in its own file group if you want to. Um, but yeah, I mean, for SQL Server, I'd say we're probably going to end up around 500 messages a second as
Hmm.
your throughput. And again, I haven't tested this at scale with multiple instances. One of the things that I've actually found is like building a reliable test rig where I have multiple Docker containers running out in Azure Container Apps connected to a Postgres instance or an Azure SQL instance, doing like firing at a command to say go and produce, a million messages and consume a million messages and then report back all the results in throughput. Building a test rig like that actually takes quite a bit of time. So I've got it started and it's sort of working, but something like that you want to make sure it works. So
Absolutely. And I mean, I can't imagine the number of times that this would have been really handy for some of the smaller but critical line of business apps I've built in my past, and I only need like 100 messages per second. So this feels
yep,
like it's going to really hit that sweet spot of I want a small, simple setup that my ops team's not going to kill me for, but lets me have that programming model that I want.
yeah, for sure. And that's what it's being designed for. It's for the people that need just enough asynchronous. And honestly, 1,000 messages a second is a lot.
Mm-hmm.
I mean, that's 60,000 messages a minute. So, we aren't talking slow, especially with Postgres. But the key is to get it in the database that you want. So whether it's SQL Server or Postgres, I think for most people that just want to do asynchronous processing, there are people out there using Quartz and Hangfire for this today, and the latency of time to run the job is significantly longer. I mean, they're not pushing even 500 jobs a second through Quartz, it's more
Mm-hmm.
like 40 or 60. So, the throughput that we're getting, and because it actually is a real broker, it isn't just simulating a transport through, just a couple of tables. It's actually built as a real broker with locking and lock timeouts and everything else. It's going to be very beneficial to apply all of those messaging patterns versus just the hang fire model of I want this job to run in an hour or I want this job to run and let me know when it's done. So,
Okay. Now, you're saying that it should feel like a real broker. It's not just, like a simple couple of tables. And I know based on our conversations that you've been super interested in bringing some of the RabbitMQ routing type functionality. I'm thinking here like routing keys and a couple of other constructs. Will those be in the database transport?
so yeah, good question. So feature set, and I put a limited feature set on kind of the docs page, but yes, it fully supports routing key exchanges. So I went with the
Mm-hmm.
topic, queue, and subscription naming for the entities. And yes, you can create a keyed subscription to say, hey, I'm only interested in routing key 427 or routing key 389. And that works exactly like a direct exchange in RabbitMQ.
Okay.
I also support um, pattern-based subscriptions where each database has its own little pattern and like syntax, like how much regex and just enough regex. But you can actually specify a pattern in the subscription, and then the SQL Server or Postgres will either do a regex match or a like match or whatever based on that pattern. So you could kind of do similar to what a topic exchange does in RabbitMQ, where you can say anything that's this. So you'll be able to subscribe to a pattern of the routing key. So that's another thing that you can do.
Awesome.
The other cool feature that even goes above that, though, is I've actually put in partition key support. And the
What
point
is
of that,
that?
so partition key, typically when you're dealing with like, when people think of partition keys, they think, oh, well, I want to use a partition key to scale out. And that's generally what we're talking about here. But the partition key can be set to any value. It's a string. And that partition key can then be used to do in-ordered FIFO delivery of messages within a partition. So you can think of it as like an Amazon SQS group ID, or you can think of it almost like a session ID in Azure Service Bus to be able to say, here's the perfect example use case for it. Job Consumers has three sagas, and those three sagas go by correlation IDs. And those correlation IDs will map to a partition key. So one of the questions that people often ask is, my sagas, I'm getting a lot of concurrency conflicts because I'm using optimistic concurrency with Redis. And I'm running 4 instances of my code, and I have hundreds of events correlating back to that same saga. Well, with the database transport, because that partition key will map to that correlation ID of the saga, you can specify a partitioned receive mode for an endpoint, and it will only process one message at a time in order in that partition, regardless of the number of instances. It locks the partition at the consumer that's consuming it, and any subsequent messages will also be delivered to that endpoint. So when you think about cache hotness and liveness, if node C is processing, job 4027, and subsequent events come into that, they're going to be delivered to that same endpoint because it's going to prefetch those messages from the queue and lock them for that node. Now, if that node craters, all of those messages get unlocked and someone else will pick them up. But the point makes it so that if you've processed a message for a particular correlation ID on one node, subsequent messages with that same partition key will continue to be delivered until everything goes quiet, and then it'll kind of recycle, and the next available node will pick it up. But it's in order delivery, and it actually supports delayed redelivery. That's kind of a delayed abandon, where it says, hey, I want to retry message 2 in 30 seconds, and that retry of message 2 will actually block the delivery of message 3 until message 2 is redelivered later in 30 seconds. So you retain that full in-order delivery. And there's actually like 5 different receive modes, because you can say, well, I don't really care about order, but I want it partitioned. And so it's just because again, we're sitting on top of a SQL database, and you can query when like partition over all day long because it's a SQL database.
Mhm.
So,
Well, that sounds cool. Talk to me. So, I got this. It's on top of the MassTransit abstraction, so I'm not having to learn anything new. I run my migrations, I get it into the database. How do I monitor this? Like, how am I gonna like check in on this? I know you said it's just SQL. Am I gonna have to join like 86 tables to see how this works?
yeah, that's something that I'm thinking about because, obviously, so the database transport is a commercial offering. It does require a license, and it will be sold separately. MassTransit continues to be open source and usable on the existing brokers, the way it is today. But the database transport will require a license, and it will there's different expectations there. So I want to be able to monitor. I want to be able to look at it. And so I've kind of looked at what kind of views I want to put on top of the data structure. So I could be able to say things like select from view queues and see like queues with the message counts, things like that. But it is SQL. I mean, and people have monitoring tools that they can currently point at SQL to say, hey, what's the count? How many messages are in this queue? And so I plan to provide some simple views for things like I want to get a queue count. I can pass it by name. I don't need to know the internal database primary keys and things like that. But that'll kind of continue to evolve as the needs ask. I mean, I know what I need, but someone will surely say, oh, well, I'm trying to query it from this, and how do I get that? So that'll be something we'll figure out. But just putting some views on top of the tables so that people can say, oh, well, I want to see all of my subscriptions. I also need this too because I need to be able to support it. And if someone says, hey, I'm getting 3 different messages here, even though CTEs shouldn't do that, I need to be able to go in and say, okay, well, like view show select star from view topology, and it will show me all of the queues, topics, and all of those topic subscriptions to those queues. So I need to be able to get that too. So looking at how that works, but that'll continue on go. But looking at some views, keeping track of how the processing goes. Another thing that was interesting is like auto delete queues. MassTransit supports auto delete queues, temporary queues, and things like message expiration. So keeping just enough metrics in the database to say, hey, this queue was last consumed from by a receive endpoint 17 minutes ago. Okay, well, if it has an auto delete of 5 minutes, I need to nuke the queue and any messages in that queue, and also get rid of any binding subscriptions to that queue so that we stop sending messages to it because it no longer exists.
Mm-hmm.
So little cleanup things like that, and just kind of administrative things around that area. So.
Awesome. So I know you said this is a commercial offering. How do I go about getting it? If I'm super interested in this, I think it's going to provide a lot of value to my company. What do I do? How do I get my hands on it?
The best thing you can do right now is just email support@masstransit.io. That'll, if you're already an existing support customer, you get access to it right away. You can play with the preview versions, so that's easy enough to do.
Mhm.
Um, if you aren't an existing support customer, we can discuss what it would take to be one, to get a support account, or depending upon your needs and requirements, experience with mass transit. We've onboarded a couple people that are just, I know my mass transit, I want to try it, and I want the feedback, so I brought a couple people in that way and just granted a temporary license to that.
Mhm.
But really, it's just we'll figure out what makes sense. We haven't established pricing yet. We don't know for sure what it's what the support model around it, whether you'll be able to buy just the transport or actually roll that into an overall support agreement where those extra features are included. Those
Mhm.
details are still being worked out. But if you want to give it a try and you want to work with it, hit that support@masstransit.io email. That'll get you logged into the system, and we have, can start that conversation.
Well, awesome, Chris. That all sounds fantastic, and I'm really looking forward to seeing some more progress and maybe getting some deep dive videos from you while it maintains to be in the triple digits in Oklahoma.
Yeah, yeah, it's definitely not time to go outside.
All right. Well, thanks, man.
All right, thanks for joining us. We'll see you at the next bus stop.